Hello, welcome to ISAT 211. So this is issues in modern production systems. It is our first lecture, Introduction to Industrial and Manufacturing Systems. So in this lecture, we'll have two parts. First, I'm gonna give you an overview about this course, talk about the grades, the topics, as well as some part of the syllabus. Another part of this course will be give you an introduction to the industrial manufacturing system, so understand what is a manufacturing system. Well, first, I have posted the syllabus on Canvas. You can access that, and find the syllabus. And my name is Hao Zhang. You can call me Dr. Zhang or call me Hao. That's my office number. And also, if you have some questions, you can always email me. And also, I hold office hours during the normal fourth semester. I'll announce the regular office hours. If it's the summer semester, usually you can send me an email to make appointment, and also I will hold 1 hour of office hour every day. Here are some of the course objectives to provide a broad understanding of the different functional areas within the manufacturing enterprise, and also let you understand the materials and manufacturing processes, as well as some system analysis in manufacturing systems. And here are the topics. The product life cycle, understand what is product design, and also will give you introduction of 3D design as well. And materials, manufacturing processes, and also production planning and control. We're also going to go over a little bit about quality control, for example, using different control charts. And then next will be the engineering economics, basically dealing with the money aspect of manufacturing systems. And lastly, we'll talk about how to improve efficiency as well as sustainability of manufacturing systems. This is our grade system. So something I need to mention is that I do not use percentage or curve. Instead, I'll just use absolute points. In our exams, assignments, labs, I will also give 5 points on bonus points. Those bonus points can be in the exam itself, or it can be a separate assignment. So how does it work? For example, the exam will be 40 points, and each problem, added that all together will be 40 points total. Same assignment. I mean, for one assignment, maybe it's only 2 or 3 points. But once you add it up all together, you will see the total points for assignment will be 30. And at the end of the semester, you can calculate how many points you actually accumulated, and then that will be converted to this letter grade scale, which means that if you get 92 above, you can get A. If you receive less than 59, you got F. You can use this chart to help you determine your letter grade. Communication wise, mainly going to use email and also Canvas. And some expectations will be you need to find your own time to study, complete assignments, and also exam. Exam have specific instructions. I'll post those instructions when it's close to the exam. And assignments. So all assignments should be submitted on time. And also make sure your submission is complete. So it will be totally your responsibility to make sure everything is okay before it's submitted. And no assignments will be accepted after due date because I'll post all the assignments, all the submissions will be online on Canvas. Once it passes due time, the submission link will disappear. For the homework itself, and you submit it online and you just scan your work and upload it on Canvas. Note that for most assignments or submissions, it has to be PDF. And my expectations on student conduct, you can go to the university website to go through those. If you need special accommodations, let me know. But first, you need to work with ODS to go through the process, and then you can let me know what your requests are. All right, now let's look at our second part of this this lecture, the introduction to industrial manufacturing systems. First, we need to ask the question is what is manufacturing? So sometimes you may see factories like on the left, a lot of the labors, a lot of stations, and it's very human labor intensive. And also sometimes you can see the factories like to the right, right? So you don't see a lot of people are going on. Mostly it's the machine doing it by itself. So basically, what is happening? This is what is happening in this world right now. There are all kinds of different manufacturing. It depends on the products, it depends on the location, and it depends on also the resources, the availability, as well as the size of the manufacturing and the level of automation. But what is the purpose of manufacturing? Of course, it's for the business, right? It's for earning money. As long as the factory can survive, it is doing okay, and also generating profit. But some, of course, you will see some factory will be highly automated. Some factory may be a little bit old school. It all happens, and I suggest you watch this video. The Gigafactory is talking about Tesla factory, and it demonstrates some of the highly motivated automated factories and how do they work in the factories. Because of the copyright issue, I'm not gonna play this video here, but I'll post the slides on Canvas, and so you should watch the video by yourself. And that's a car, Tesla, that's a car manufacturer. Here is another video, is to build a rocket, right? You will see, how different it is. A car, manufacturer, they can make maybe hundreds of thousands of cars for months or for a year, but for the rocket, maybe for a whole year they won't be able to make a lot. So it's very more project based, and also the layout and how do they organize the resources also be very different, depending on the product. So watch this video and see how a rocket is made in the manufacturing company, and how different it is from making auto vehicles. And of course, we see some bigger things like cars, the rockets, and you can watch those videos and see how they can actually make fast food, right? So the fast food can also form a very simple assembly line. For example, Jimmy John's, the one you are watching in this video, is that Jimmy John from this only 2 or 3 workers, of this production flow, and then it makes the whole process pretty fast and to make a sandwich. So, and they actually borrow the concept from manufacturing, forming a production line. And this is also application of industrial manufacturing systems, right? Similarly, we can apply the similar principle to some other industry, for example, the airport. So airport, what they're processing the customers, the passengers, right? You get into the airport store, you need to go through the, the security, the check-in, and then, waiting, in the, in front of the door. And so that's all operations. And how do you make this whole process more efficient? You probably want to analyze the cycle times of each process, how many stations need to be involved or need to be open. And these all decisions are based on analysis that we'll need to learn in this class. Okay, so it's similar to the manufacturing. Another one will be the Disney World. If you have been there, you'll see there are a lot of waiting in there. And so how do you deal with those waiting times? How do you make how can you process or accept as many customers as possible with only 1 days of time. So that's also we can borrow a lot of these operation concepts or principles from the manufacturing to those industry. So what I'm saying is, what we are learning in this course is not just limited to the manufacturing companies that are making physical products, but also it can be applied to a lot of other service industries. All right. So first, let's look at from a product perspective and where this manufacturing it is, right? So we know that at the very beginning stage, we start with the material extraction, and this is where we get the material from the ecosystem, and then for example, iron ores, right? And then what next do is what we need to do is to process iron ore to become certain maybe metal sheets, right? Material processing companies or facilities. Those metal sheets will be transported to the manufacturing company, which ones will be converted into a car or some other equipment, or for the metal equipment. And then after that, it will be distributed to the customers. And then the customers, after you use it for 10 years or some years, you'll figure out, it's not working anymore, or you want to get a new one, then that's what to do. There are multiple ways you can do. One is, of course, to send it to landfill. Eventually, it will be a part of nature, but it might take a very, 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 very long time, and to dispose it in the landfill. And this is something we want to, avoid. Also, another way we can do is to sell it, sell it to some other ones, like secondhand, products. Well, in this case, basically you are selling it to other users, which means that they actually enter another product life cycle. So this is another way to approach that. Also, you can do recycle. Maybe some materials or some parts can be recycled and be reprocessed into the metal sheets as well. So actually, in this world, we are doing this, because in most of the metal processing companies or steel making companies, they actually use 30% of the charge are from recycled scraps. And also, your products can be remanufactured for example, refurbished, products to be some good products to sell it again, and maybe at a cheaper price. These are all different ways that you can actually extend the product life, and then or let it into another life cycle here. And this is how we look at the product from its life cycle perspective. And now we look at a product. Now let's look at, how do you define a manufacturing system? As I just mentioned before, there are different kind of manufacturing systems. Some are very small, old-fashioned. Some might be, very automated. It's like very modern manufacturing company without a lot of employees, but everything is so automated. And they all vary a lot, but they are, regardless of what kind of companies, what is the high level of automation. And there are some basic components that, in there. For example, we start with materials, some engineering materials, and then we have manufacturing processes to convert the materials into a final product. But those processes are actually managed by some support systems. For example, how do you arrange a schedule? How do you plan? How do you, facility planning? How do you control the quality? All of those things are actually to make this manufacturing system is efficient, and also operations, in a good state. So this is a manufacturing system that is something in common, regardless of what type of manufacturing system it is. And in the manufacturing system, there are also different rules. You can see some people might work as the product designer, some people might be the manufacturing system engineer, some of them can be, say, supply chain and the logistics. Some people may be the scheduler, or maybe operations manager, or some of those can be a continuous improvement to improve the efficiency or conducting analysis, for example, industrial engineers. So whole manufacturing company, and they actually, there are a lot of opportunities for people with different backgrounds. And I suggest you watch those videos and then see how those people actually talk about their own job in the manufacturing system. And so here I want to talk a little bit about our curriculum here. So if you're interested in pursuing a manufacturing or industrial engineering or operations management career, so the industrial manufacturing sector will help you prepare for that career goal at a college level. So second year here, this is 211. And 211, we talk about the principles of making, designing, and also continuous improvement, system of production systems. Those concepts are mainly at the introductory level. And in the third year, if you choose to take it as a sector class, then there are 3 classes we're offering. One is 330. 330 is the production planning control. We talk about computer integrated manufacturing, facility layout, capacity planning, forecasting, inventory control, scheduling, supply chain, quality control, engineering economics. So basically, this is a very similar course to the operations management course in business school. And after you learn this, you should be good or better prepare you to be an operations manager or maybe an operations engineer or industrial engineer positions, at least from interns. It should be sufficient. Well, another course is 331, cyber physical industry. It covers 3 aspects. The one is manufacturing automation, human factors of economics, and as well as cyber physical systems. So in 331, you will learn, what are the physical components like sensors, actuators, motors, and how do they work, how do they form a automation system, and as well as how the controls for these automated systems. For example, PLC control or some digital control, and as well as you will learn some concept, or get familiar with industrial robotics, what type of robotics, what are configurations, or what can they do, and how do you control them, those kind of things. And material storage, the automated systems, automatic, retrieval and also storing, and as well as some inspection devices. And another component will be the human factors and ergonomics. So which means that, in our manufacturing system, you also need to take care of or consider the healthy part, and also how to make the interface. For example, if you're designing a workspace or workstation, make sure that, the workstation you design is ergonomic, right? So your workers, or your employees won't get hurt by doing chronic work. And so we're going to talk about displays, controls, how to design displays and controls to make it interface easier to understand. Cognition, decision making, engineering, anthropometry, workstation design, biomechanics, stress and workload, as well as human computer interactions. Another component of that is cyber physical systems. So it includes some Internet of Things that apply to manufacturing systems, machine to machine, industrial monitor systems as well, and also critical infrastructure, smart cities. We'll also talk about blockchain system technology in here as well. So that's the 2 major courses at the sector level. There's also 1 lab course. Mainly we're going to talk about or give you some more hands-on experience about designing a physical system, an automated system. So you can apply what you learn in 331 into a more of a physical project. And if you are thinking of pursue a career in industrial engineering or manufacturing systems, And we have a lot of courses offered at the junior and the senior year level, or at concentration level. So one is the materials and manufacturing processes. So here we're going to get into a little more depth into the different materials. For example, glass, wood, plastics, metal, all of those. What are these properties, and how to manipulate those properties to adjust the quality of the products. Also, I'm going to talk about multiple common manufacturing processes. For example, machining, processing metals and ceramics, metal forming, and how to for example, injection molding for plastics, property enhancing, how to you control the surface of the property of the products. And also, I want to talk about different assembly processes, including the joining as well as the manual assembly processes. In that course, 430 material manufacturing processes, we have a lab session. The lab will be mainly automated design and manufacturing. So you will learn, getting the more deep detail or depths of using the 3D design, computer-aided manufacturing, how do you convert a 3D design into a into a program or language that can be read by the machining centers. So, and also learn product design, life cycle assessment, as well as GD&T. Here, we're going to typically want to use a clock making project, so you can we can work through the whole process from designing the clock, converting to a CAM programs. And then you make those kind of products with our machines in the lab, and then you get a final product. Another course, required course in our concentration is the Lean Six Sigma and continuous improvement. So for here, this is more a management part of the industrial manufacturing systems, and here you will learn a lot of those management concepts. For example, lean principles, Kanban system, Toyota production management, supply chain, just-in-time, value stream mapping. This mainly for continuous improvement, and some of you might have heard about like yellow belt, green belt, and black belt of Six Sigma, because Six Sigma has been widely used in many industry and also service for quality control. So this is also one of the key areas in manufacturing systems. Some other courses we offer include micro nano manufacturing and additive manufacturing processes. For example, I'm interested in laser technology, in nano manufacturing, in 3D printing. So here are here's the course that you can take. We also have another course. It's called Technological Innovation and Sustainable Design. Here I want to talk about different technologies that can be used in manufacturing systems. It can be, maybe you will design a smart system for collecting data, and then our automated system. And also you're going to learn a lot about the policy and the relations between the technology and the design process. All right, so that's about the curriculum, and hopefully this overview can help you understand what you will learn in industrial manufacturing system sector. In the end, I want to talk about the history of the industrial manufacturing systems. It really we look at its history from two aspects or two perspectives. One is from technology perspective, the other one is from management perspective. First, technology perspective, we all know that automation or the recent industry is really started from the mechanization, in the industrial revolution, right? And then the second stage is the mass production. The mass production really started from earlier of last century. In that case, people make it a lot easier to form the production line, and there will be it significantly reduce the cycle time of making products. So this is how the mass production works. And then later, after Second World War, people started the technology revolution, and computer was invented, and now people are doing more of automation in manufacturing systems. So the next stage, or something that we're already working on right now, is Industry 4.0, which is using data, using digital control for manufacturing system. I suggest you watch this video, Industrial Revolution, so you understand the history of that technology perspective. And then from management perspective, we also can look at it from at different stages. For example, at the very beginning, ISAT Whitney. ISAT Whitney is famous for inventing the cotton gin, but also he has a very good invention that is interchangeable parts. So for guns, and using interchangeable parts means that you can actually produce a lot of different parts, and then when something is failed, and you just need to replace one part instead of remake the product again. So it significantly improve the efficiency of making products. Well, another stage will be the Ford and Taylor. So Ford and Taylor, they form the production line. So even at very early stage, people are making a product, they are making a whole product at once. Didn't really have a production line, and then Ford and Taylor did the innovation that they made the product, or the semi-made product, or material, to move, and instead having the employees and operators to stand still, and then all the parts will be move along the production line. And this means that each operator only needs to finish one simple task, and this is how it actually reduces the cycle time. And later, when I talk about cycle time analysis, you will understand why dividing the work, dividing the job into multiple stations, that can actually greatly save cycle time. And next stage is damming. So damming really is damming, and also talk about production system. They're all looking at the quality control. How can you make products with less quality issues, with higher reliable production systems that it can save you a lot of money, right? Make more products with less money. So this is what they are doing. And damming used the statistical analysis for quality control. And well, Toyota production system, instead, they created actually more like a tool set, right? Toolkit of different methods to identify the problems, and then how to solve it. And then also some of the things, for example, Kanban system to do the pull system, means that you only make what you need, instead of the push system that you produce as much materials as you have. So this is the two different things, and these are the 4 different levels of or 4 different stages of the manufacturing history from the management perspective. And that's pretty much for this lecture. And the takeaways for this lecture will be: understand what is manufacturing, understand what is manufacturing system, and also have a general idea about what is the history of technology in manufacturing, and also the history of management in manufacturing. That's all for today.